What is integration? For a student who is at normal educational level, I think it is not very difficult to answer, even though I choose to produce such a huge video to show you how to understand it in physics perspective. To realize this, I found a problem for you. We consider this situation. There is a long stick nearby a massive point, which the point is on the perpendicular bisector of the stick, or the same straight line where the stick is at. How much is the gravitational force acting on the massive point according to the long stick? The animation below illustrates those two situations. Please pause this video and try to think it individually at first. Now let's look at the basic theory, gravitational theory. This is about two massive dots, which one is red and the other is green. The distance between them is r, and the mass are m1 and m2, respectively. It is known to all that the gravitational force between them is gravitational constant times m1 and m2 divided by r squared. This force of attraction will get changed if the distance changes, while keeping their mass constant. But now, let's think further. What if the massive point no longer be a point? I mean, for example, be a block or something. Yeah, you could surely say that it doesn't matter, thus we only need to calculate its mass center. But what if the block becomes bigger, and even more bigger? In this way, the forces are not balanced on each point on the object, and this is the situation we are facing. Now I will introduce a special method to make sure that everything is going on the right track. That is called integration, which is calculate the sum of each value of a specific function. For here, we mainly use it to calculate each attractive force of point on the stick, then sum up to get its accurate value of the gravitational attraction acts on the point. We cut the stick into small parts. Those small parts are so tiny that we can even consider each of them as a piece of paper, which is in 2 dimensions and only have tiny thickness. We just need to calculate each in gravitational formula. Assume that the mass of the massive point is m, while the mass of the whole stick is capital M. Let the length of each piece of the stick is dx, which x here stands for the length of the stick, and d here stands for the small amount of change in distance. Now we can start. Consider the second situation, as it seems to be easier. Make those two things arrange in the same straight line, which the point is on the left-hand side of the stick. Firstly, create a single-dimension coordinate system, which let the point be the origin and only have x-axis. To make things clear, I drag the axis down a little bit so it is more easier for you to understand. Then, let the distance between the left end of the stick and the point be a, and the length of stick be l, which means the position of the right end is a plus l. Secondly, calculate a single piece of stick. We assume that the length of each piece is dx, so the whole stick is divided into L over dx pieces. Due to the total mass is capital M, mass of each piece is m times dx divided by L. Then we move on to the formula by simple calculation and substitute what we have already known into the equation. We can find out that this piece has the force of the product of gravitational constant capital M dx and small m divided by L and x squared. Remember, this is only one piece. We need to add all of them together, which is so-called integration. It seems hard but really simple, which from basic words is write an integration sign and starting point at the bottom, that is the distance from the left, a, and ending point at the top, that is the distance from the right, a plus l. Then, by calculators, or maybe your brain, use the knowledge you have learned, integrate an equation, and we get the final answer. Then comes the first situation, which is the point is on a perpendicular bisector, create a coordinate system which is two-dimensional with the origin at the midpoint of the rod, marked as letter O. Again, let the distance between measure point and origin be A. Assume that for each piece, the left-hand edge has the position of x0, which the distance to the origin is x. Same as the second one we have already discussed, for each piece of stick, we have the force of the product of gravitational constant, capital M, dx and small m divided by L and y squared. That y here is the distance between the piece and the measure point. Notice the Pythagoras theorem that the sum of the squares on the legs of a right angle is equal to the square on the hypotenuse. We can express the distance y in terms of x and a. That's y equals to the square root of a squared and x squared. Substitute into the formula. That is the force of simple piece act on the point. But things become a little bit different here. That the force is a vector. It has direction. That two opposite forces may sometimes cancel each other. Review that piece of rod. Factorize the force into vertical and horizontal directions, marked as Fx and Fy. To tell you the truth, we don't have to calculate Fx, since two same pieces, which both of them enjoy the same distance to the origin, can cancel each other's horizontal force. Now, we should move on to the Fy. From Pythagoras' theorem, we know that the ratio of A and C is A over the square root of A squared and B squared. See the situation here. That ratio is A over the square root of A squared and X squared. So Fy is the product of gravitational constants, capital M, small m, and dx, divided by L and A squared and X squared times A over the square root of A squared and X squared. Now the following words are repeated. Remember, this is only one piece. We only need to add all of them together, which is so-called integration. It seems hard, but really simple, which from basic words is write an integration sign and starting point at the bottom, that is the distance from the left, minus L over 2, and ending point at the top, that is the distance from the right, positive L over 2. Then by calculators, or maybe your brain, use the knowledge you have learned. Integrate the equation and we'll get the final answer. The whole question ended here. All the deductions are written here. But to tell you the truth, if you are a high school student and prepare to study physics in the near future, I have no doubt that you can work out this problem easily, which all of the animations I've done are useless. However, this is not the real purpose I make this video, but to invite a heated discussion of what is the use of integration, or even further, for all mathematical methods. We know that since ancient times, equations are founded in order to solve unknown values, especially when calculating the behavior of materials and forces. Also, geometry, phase space, a strong and energetic method of analyzing fields, from gravitation to electric, from magnetic to nuclear. What's more, linear algebra, mainly used in quantum physics, geometric force method by Bohr's model of hydrogen, and Heisenberg's uncertainty principle. In addition, typology. Gauss' law and Ampere's law in electrodynamics are both typological in nature. Last but not least, integration. The main topic today. From my perspective, the use of integration is just to sum up everything that human cannot exactly and directly calculate. Cut everything into small pieces, so that the mistakes can even not be able to consider. Then sum up. There's nothing interesting and fresh. Math is used for physics. Math is the tool of physics. Since the Philosophia, Naturalis Principia Mathematica was first published on July 5th, 1687, a great revolution in physics has spread the light of mathematics on science, which up to then has remained in darkness of conjectures and hypotheses. Since then, more and more fields are occupied by physics, especially after the 20th century, when Heisenberg's work on the spectrum of hydrogen atoms in quantum mechanics broke the gap between chemistry and physics. It can be said that physics, as the principle of everything, is the study of everything in the universe, from the sea of the stars and planets to the strange and charming quarks. All of them can be covered by this precise and uncertain word, and that's why I wanted to devote myself on physics. And here's the reference list.